Unit 3, File System Structure and System Calls. So the topics that are to be covered in Unit 3 are file structure, directories, files and devices, and so on. Now we will start the first topic, that is file structure. In Unix, files plays a very major role, not only in Unix, in the Linux environment also. It will play a very major role. That is, files are very important because they provide a simple and consistent interface to the operating system, services, and devices. An operating system is responsible to provide services for the user, and it will provide some services for the devices. In Linux, everything is treated as a file. We need to use only 5 basic functions in order to use everything as a file. The 5 basic functions are open, close, read, write, and IOCTL. So these are the 5 basic functions that are required in order to work with a file in a Linux system. File in the sense it may be a directory, it may be a file, or it may be a device, anything. Everything in Linux is treated as a file. And directories are also special sort of files. And in modern Unix versions, including Linux, even the superuser may not write the data, or superuser cannot write the files or create the files into the directory directly. So all the users ordinarily use some high-level interfaces like open dir or read dir to read the directories or to open the directories without needing to know the system-specific details of the directory implementation. That means how the directory is implemented, what are the details behind the directory implementation is not necessary for the user, and it is not displayed for the user also, because it is providing some high-level interface like open dir or read dir as an interface to the user to read the directories or to open the directories. And directories, as I specified just now, it contains some content. That means it contains some files. A file has some properties. So the properties of the file, in the sense it may contain the name of the file, then it may contain some properties like some administrative information, and it may contain some properties like when it was last modified, when it was created, by whom it was created, who is the owner of the file. So these are the properties that are available for every file in the system. Hope you can understand what are the list of properties that are available for the file now. It may be a name, it may be a date when it was created and when it was modified, when it was last accessed, everything related to the particular file. And it may contain some information like who it was created and what is the location of the file, what is the size of the file, everything will be available in the properties of the file. So these properties information are stored in the files inode in case of Linux. We are calling it as inode. The properties of the file like name, everything that I have specified just now will be stored in files inode. So which is a special block of data in the file system, and it also contains some length of the file, like I specified just now, there is a size of the file, and where the file is stored on the disk, there is a location, and the system uses some number of file inode numbers. That means the system is going to use, system in the sense, don't think it as a physical system, it is an operating system. The operating system uses the number of files inode, and the directory structure just names the file for our benefit. That means the operating system will be able to identify the file based on the inode number, but not based on the name. The name for the file is given for the sake of convenience for the user, because as a human we can understand only the name. A directory is a file which holds some inode numbers and the names of other files, and also each directory entry is linked with file's inode number. When I use ln space hyphen I, then it shows what is the inode number of a particular file. Example, if I have a directory called X in my Linux system, within that directory X, if I have ABC file and BCD file, if I have two files, and if you want to know the inode number of BCD, then I have to specify ln space hyphen I space X forward slash BCD. I have forward slash as root in Linux operating system. And in this root, I have a subdirectory called home, that is slash home, that is a subdirectory where when the user logs in, the home directory will be logged in, that means it will be accessed, which will be the output of the present working directory that shows the current directory, which is the home directory. And the root directory normally includes some other files like slash bin, that is for binary system programs where the executable files are stored in slash bin, and it may also contain slash etc. So normally it is called as miscellaneous file. So where it can contain some system configuration, so we can call it as system configuration files. Slash etc is also called system configuration files. That means we are going to store some configuration information regarding the system in terms of files, and that files will be stored in slash etc. And slash lib, so that is a system library folder or directory where we are going to store some system libraries. So files that represent physical devices and provide the interface to those devices are conventionally found in a directory called slash deb. So now in Linux, I specified that inode contains the details of the file like name, some properties like when the file is created, when it was last modified, etc. And some administrative information like some properties of the file will be stored in inode, so which will be given with some number, and with the help of that number, the files will be accessed in Linux, but not with the name. The name is identifiable, or it will be helpful only for the human being to understand that the particular file is opened or created or modified or edited. We'll show you a hierarchy of the Linux file structure, so which contains a root directory followed by the binary files, the device files, and home directory. So within the home directory, I may have different types of users like mail and Rick. And if I consider mail as a user, and if you want to work with that particular user, I may have different types of files or applications stored in that particular home directory in mail. Like mail is one kind of directory, or letters is one kind of directory, or programs is one kind of directory, etc. Or it may contain programs as a file, or letters as a file, etc. So likewise, we have some files and directories that are maintained in some hierarchical fashion where forward slash is the root in Linux environment, but in case of Windows environment, C colon slash greater than symbol. It is then the C colon is the root directory in case of Windows environment. Like that, we have forward slash as root in the Linux environment. So this is the hierarchy of the file structure. And now we will see the next topic, that is files and devices. Here I have a small question, that is how the hardware devices are represented by. So based on the discussion in the previous concept, in Linux environment, we are saying that everything is treated as a file. Now, how the hardware devices are represented by? The hardware devices just now has specified if I connected mouse, or if I connected printer, or if I connected any devices to the system, those will be treated as files, and that files will be represented in slash device files. So the hardware devices are represented by files only. So for example, as a super user, we can mount the IDE CD-ROM, that means integrated drive electronic CD-ROM drive file, which will be treated as a file, and I can integrate, that means I can mount this, mount in the sense I can attach the CD-ROM drive to the system with the help of the command, with the help of the following command logically, that is mount space -t space the ISO 9660, that is the standard of the particular CD-ROM drive, or to the particular primary drive that we want to connect. So slash DEV slash HDC is the secondary master IDE device that is attached to the system, and slash MNT slash CD-ROM, where slash MNT means it is a mounting, that is a mounted folder in which the CD-ROM device is attached. And when we enter the command cd space slash MNT slash CD-ROM, so it is like changing the current directory. Earlier, it may be in the directory called /dev/sdc. Then, when it was changed to mount/cdrom with the help of cd command, that is a change directory I have applied. So, we have three important device files that are available in the Linux and both Unix environment also. So, they are /dev/console. That means I am specifying most important device files. We may have some other device files like if you observe here, I have /dev/sdc is available. Likewise, we have several other devices that are connected to the system and that files will be available in /dev. But the most important files that we are going to consider here are /dev/console, /dev/pty, and /dev/null. These are the three different devices that we have. And the /dev/console represents the system console. With the help of this system console, the error messages and diagnostics information are often sent to the devices. Each Unix system has some terminal, some designated terminal or screen to receive the console messages. So that is that kind of files are available in /dev/console, and at one time it might have been a dedicated printing terminal. And on modern workstations on Linux system, it is usually the active virtual console. That means if I use printer as a if I use printer to print the data, so at a time it is not possible to use the same printer to print some other data from some other file. Example, if I have some X and Y files, currently I am printing the document of currently I am printing the data from X file. Meanwhile, if I want to print the data from Y file, it is not possible because we have some dedicated printing terminal. So the terminal will be applicable only for one file at a time. And in most of the workstations, in case of modern workstations in Linux, it is usually the active virtual console. So that we have the dedicated printing terminal. And /dev/tty is another device file that is available, which is an alias for logical device for controlling the terminal of a process, where the process may be connected with a keyboard, or a process may be connected with a screen, or a process may be connected with some window, or it may be connected with some application, anything. If a process has one, either it may be keyboard or monitor or the screen or that is connected to a process, then we can control that terminal with the help of this /dev/tty. For example, processes and scripts running automatically by the system won't have a controlling terminal. So therefore, we cannot able to open /dev/tty. And it can be used. That means /dev/tty can also be used to allow the program to write the data directly to the user. So without regard to which pseudo terminal or which hardware terminal the user is using, irrespective of the terminal type or terminal name, so the user is using, we can straight away write the data to the user. So that is the flexibility of using this /dev/tty. And I will give one example here. If I use a command for long listing the directories like ls space -R, which is similar to the long listing of files with ls space -L. Where in case of ls space -L, it will long list all the files and directories. But if you want to display the long directory listing as a group of pages, then I have to specify the command ls space -R pipe operator with more command. So when I use this, the program more has to prompt the user for each new page of the output. That means the more command is prompting the user. Means the more command is trying to write something onto the file, onto the screen to the user. So how it is possible is with the help of /dev/tty. So which will allow the program to write the data directly to the user on the screen. And the last file is /dev/null. So the /dev/null is a null file. That means all the output returned to the device. If, for example, if I use the cp command, so in case of cp command, I need to specify the source file name and destination file name. Here the destination file name here is np_file, and the source file name here is /dev/null. For example, if I have instead of these two file names, if I have the file names like x and y, assume that the x contains some data like echo command with some hello string, and y contains some data with echo command with some hello world as a string. So now, if I want to copy the data from x to some a, where a is a file which is not exist, or if it is exist, it may contain with some data. When we want to copy the data into the file, it may override that. The concept you may know. That is with the help of cp command. So while I am copying the data from one file to another file, it will write the data temporarily into a file called /dev/null, which is a null device. And once the output is written onto the particular file, that means I want to copy the data from X to A. So meanwhile, it is checking, the system is going to check whether the file A is available or not and what is the data available in X. If it wants to copy the data from X to A, it has to look into the data that is available in X, and it will read the data and it will store it in some temporary location that is called /dev/null, which is a null device. And from there, it is going to write the data to the destination file, that is A. If the file does not exist, it will create a file and it will write the data into it. So here, while copying the data from one file to another file, we need some temporary location where the data will be stored. So that is called /dev/null file, and it will be discarded once the data is written onto the device. That is written onto the destination file. An immediate end of the file is returned when the device is read, and it can be used as a source of the empty file by using the cp command. That is shown in the screen. And the unwanted output of is often redirected to /dev/null. That means if I don't want this kind of output that is to be copied from one file to another file, that kind of information is also written onto /dev/null. Only the necessary information will be written onto the destination file, and the data will be discarded or terminated automatically once the operation is completed. So that is the use of /cp/dev/null empty file. And when I print the file name, that means echo, do not want to see this, space greater than /dev/null. When I print this, then it will display what is the output in the particular file. And we have some other devices in /dev, so which may include some hard and floppy disk. That is a hard disk drives and floppy disk drives, communication ports, tape drives, CD-ROMs, sound cards, and some other devices representing some system's internal state, like what is the time and date of the system. And there is even we have one more file like the /dev/0. There is one more file, that is the /dev/0, which acts as the source of the null bytes to create the files with full of zeros. Earlier, in case of null file, it is written with the data that we are having in case of source file, and that will be discarded automatically once that operation is completed. But in case of /dev/0, it will act as a source of null bytes to create the files with full of zeros. And we need to we need some super user permissions to access some of these devices. Normally, it may be /dev/console, or it may be TTY, or it may be null or zero. So we need some super user permissions to access some of these device files. Normal users cannot write the data or programs to directly to access the low-level devices like hard disk. And the names of the device files may vary from system to system. Here I may use the device files as console, TTY, null, zero, etc. But in another version of Unix operating system, or in case of another Linux operating system, the names of the device files may vary. And the Linux distributions usually have some applications that run to manage the devices that would otherwise be inaccessible. For example, if I use the mount command, that means if I want to mount for user mountable file system, then it is then the devices are classified as either character devices or block devices. That means we have different types of classifications of devices here. That is the character device files and block device files. The most important difference here is it refers to the fact that some devices need to be accessed as a block at a time. And typically, the only block devices are those that support some type of some file system like hard disk. That means when I want to copy the data from one file to another file, I need to copy some block of data at a time. But when I'm using some keyboard type of device, then I need to use some character devices. That means a keyboard is a character device. At a time, we can type only one character, and it will read only one character. The system is going to read only one character. But when I want to copy the data from one file to another file, it is going to read some block of data, and it will write some block of data onto the system. So we have two different types of devices required here. One is block devices, where we can access the block data, and we can read and write the block data accordingly. And we can also use some character devices, where we can read the characters from the devices, and we can write the characters to the storage location. So in that case, we have to use this character device files and block device files, which are some other files that are available in /dev. So likewise, we have several other files that are available in the Linux environment, but the most important device that we have are /dev/console, /dev/pty, /dev/null, and 05. So these are the different types of device files available in Linux environment.